Welcome to T1 Day 19 of Honors Precalculus. Today we're going to talk about angular and linear velocity. The first term we need to understand is the idea of a nautical mile, and this is the length of 1 minute of arc along the Earth's equator. Remember that 1 degree equals 60 minutes. 60 minutes. So this is not to scale, but the idea is the nautical mile is the distance from point A to B. So from point A to B on the Earth, if this angle right here is 1 minute, Now the arc length formula allows us to convert between nautical miles and statute miles, the familiar land mile of 5,280 feet. That whole weird thing that we have where 1 mile on land that we use is called a statute mile. It's 5,280 feet. And the radius of the Earth is approximately 3,956 statute miles. These are key pieces of information. So what we have here is a conversion of 1 minute to a certain number of radians. How do you do that? Well, 1 minute is going to be equal to 1/60th of a degree. But 1 radian, so pi radians, is 180 degrees. So this is just a fancy way of writing the number 1. So when you multiply by 1, it doesn't change anything. So again, 1 minute is 1/60th of a degree. So what does that mean this conversion comes out to be? It means that 1 minute is pi over 10,800 radians. And this is useful for our next conversion. So you might remember from yesterday that arc length, we had a formula which was going to be theta over 360, and this was in degrees, times 2 pi r, which is the circumference of a circle. Now, this was in degrees. If we wanted it in radians, it would be very similar. It would be instead theta over 2 pi, because there are 2 pi radians in one circle, and it's still 2 pi r for the circumference. But what's interesting here is that this cancels the 2 pi, and you're left with pi times r. So in radians, arc length is pi times r. That's what this is right here. S equals r times theta, So the arc length of 1 nautical mile, is therefore r. In that case, it's of the Earth is 3,956 miles times theta, which is pi over 10,800. So what that means is 1 nautical mile is equal to this product right here. If you do that out, you end up with 1 nautical mile is 1.151 statute miles, and 1 regular mile is 0.869 nautical miles. So what this means is a nautical mile is longer than a statute mile. So in this question, a pilot for Western Airlines is flying from Boston to San Francisco, which is 2,698 statute miles. So 2,698 statute miles, and those are the regular miles that you know. And Captain McCarthy's calculations of the flight time are based on nautical miles. How many nautical miles is it from Boston to San Francisco? Well, we have our conversion right here. These are statute miles. So we need to multiply 2,698. We need to multiply that by 0.869 to get nautical miles. And it comes out to 2,344.562 nautical miles. The next thing we're going to look at is 2 different ways to look at velocity. One of them is linear velocity, which is just distance over time. And we've seen that as miles per hour or meters per second, and there's lots of other measurements or units for linear velocity. Another way to look at velocity is angular velocity, the change in degrees over time, which could be degrees per minute or radians per second. Those are 2 units for angular velocity. So how do we go about converting between these things? So for example, Determine the angular velocity in radians per second of a wheel turning at 300 revolutions per minute. That's what it means, revolutions per minute. So that's 350 revolutions per minute. Well, there is 1 minute is the same thing as 60 seconds. And we know that 2 pi radians is the same thing as 1 revolution. 1 time around the circle is 2 pi radians, which is 1 revolution. When you cancel these things, the minutes cancel right here. And then you end up with 700 pi over 60. And that's equal to 300, that's 35 pi, divided by 10 and then cut it in half over 3, and that's going to be radians per second. What about if you had to determine the RPM of a wheel turning at a rate of 52.8 radians per second? Well, you're going to do something similar. Remember, you're going to start with 52.8 radians per second. That's 1 second. And there are 60 seconds in 1 minute, and then there's 1 revolution is equal to 2 pi radians. So what happens here, what cancels? The radians cancel right there, the seconds cancel right there. So what you end up with is, you do this out, you end up with 504.203, if you do all this division out, revolutions per minute. Because you end up with 1 revolution on top, and minute on the bottom, RPM, revolutions per minute. So this has 2 things asking about a Ferris wheel that has a diameter of 220 feet and takes 42 seconds to rotate once. Determine the angular velocity, so that's something like radians per second. Oh, it actually told us that, yay, of the Ferris wheel. So we know it's 1 revolution in 42 seconds. Well, there are 2 pi radians in 1 revolution. 1 time around is 2 pi radians. Well, that's just going to be 2 pi over 42, which is equal to pi over 21 radians per second. Yay! Determine the linear velocity in feet per second of a person riding the Ferris wheel. Well, the way you do that is you're going to end up with pi over 21 radians per second. What we're going to multiply this by is 110 feet over is equal to 1 radian. And that's because this Ferris wheel has a diameter of 220, so its radius is 110. That means the arc length of 1 radian, is 110. The arc length of 1 radian is 110. So what this comes out to be is 110 pi over 21, and the radians cancel. You end up with 110 over pi feet per second, which is about 16.456 feet per second. I really like 3 decimal places. So this one says the minute hand of a watch is 1.3 centimeters long. So you have this watch right here, and the minute hand is 1.3 centimeters long. Okay. What is the linear velocity in centimeters per second of the tip of the hand? Well, we know that 1 revolution of the minute hand will take 1 revolution will take 60 minutes. The minute hand goes around once every 60 minutes. And then you're going to multiply it by however long it takes for it to travel. The tip goes in 1 revolution. Well, if the radius of the circle is 1.3 centimeters, the circumference of the circle is 2.6 pi centimeters, because we know that circumference is equal to 2 pi r, and in this case r is 1.3. So 1 revolution, it travels 2.6 pi centimeters, and in 1 minute there is 60 seconds. So what do you end up with here? What cancels? Well, the minutes cancel right there, and you end up with, and the revolutions cancel right there, you end up with 2.6 pi over 3,600 centimeters per second. So it's moving pretty slowly, which makes sense because it's the minute hand. It's 0.00227 centimeters per second. And yes, this is longer than 3 decimal places. So you're looking for equivalent things. 2.6 pi centimeters is 1 revolution of the minute hand, and 1 minute is 60 seconds. So suppose a bike tire has a radius of 12 inches. You have a bike tire radius of 12 inches. Is spinning at a rate of 3 revolutions per second. It's pretty fast. How fast is the bike traveling in feet per minute? So what's going on here is, you know that it's going 36 radians per second because it's 3 revolutions. Whoops, small mistake there. I'm sorry. I meant to say it's going to be 3 revolutions per second. And there are 60 seconds in 1 minute, and there are 24 pi inches in 1 revolution. That's the circumference right there. That's the circumference. Circumference, 24 pi. Because how do you get that? Well, you know that the circumference is equal to 2 pi r, and the r in this case is 12. So that's where the 24 pi comes from. There's 24 pi inches in 1 revolution. That's the distance all the way around 1 circle. And the last thing you know is that there's, in 1 foot, there's 12 inches. So when you do this all out, you end up with 180, a lot of things cancel, times 24 pi all over 12 feet per minute. Because what cancels here, you end up with the seconds canceling, the revolution canceling, and the inches canceling, and you're left with feet in minutes. So you end up with 360 pi feet per minute, which is about 1,130.973 feet per minute. So now let's determine the linear velocity in inches per minute of a point on a tire of radius 12 inches that rotates at 36 radians per second. So that means you have rotating at, 36 radians per second. Okay. And then there are 60 seconds in 1 minute. And then there are 12 inches in 1 radian. So those are all things that allow us to cancel seconds here, and then radians here. And then what are you left with? You're left with 25,920 inches per minute. It's all about multiplying by things that are equal to each other over things that are equal to the top and bottom. So you end up with 60 seconds is 1 minute, 12 inches in 1 radian. Those top and bottoms are equivalent. The units cancel, leaving you with just the units you want, inches and minutes. This just takes practice, like so many things.